Today we're looking at finding vertical and horizontal asymptotes of a rational function, and we're looking at sketching the graph of a rational function. Okay? So first of all, we need to know what a rational function is. What is a rational function? Anybody know? Talk about a rational number. What's a rational number? Alright, it's a number that can be written as a fraction. So when we're talking about a rational function, all we're talking about is two polynomials that are written as a fraction. So I've got a polynomial on top of another polynomial. That's what we're talking about with a rational function. Okay, so we want to find vertical and horizontal asymptotes, and then we want to use that information to help us sketch it. So here's our first example. The first few examples we're going to go through and find vertical asymptotes, horizontal asymptotes, and the domain of them. Okay? And on all of these, what should the domain start with? It should start with all real numbers because it's not going to have a what? It's not going to have a square root. So the domain should be pretty easy. Alright, so if I'm looking for vertical asymptotes, I'm interested in what makes the denominator 0. Okay? What makes the denominator 0 will more than likely produce a vertical asymptote. Sometimes it won't, but most of the time it will. So what can I do to x squared minus 4 that's going to help me figure out what's going to make it 0? I can set it equal to 0, but we want to factor it. So I do x minus 2, x plus 2. What type of factoring is that called again? Difference of 2 squares. Excellent. Okay, so after we factor, we can now see that what's going to make my denominator 0? Positive and negative 2. So my vertical asymptotes are going to be x equals 2 and x equals negative 2. That's how I want it written down. So what is graphically going on at a vertical asymptote? And we'll look at a graph here in a second to verify what you guys are thinking. I want to know what you're thinking already. What goes on at vertical asymptote?
Is that where it's going to get as close as the line to it as it can, but it won't actually touch?
It's going to get close to the line. It's not actually going to touch. So what two directions is a graph going to go as you get closer and closer to an asymptote? Down or up. Okay, that's what a vertical asymptote tells us. I know my graph is either going to go up or down as I get closer and closer to the vertical asymptote. So that's what's helpful about that. Okay. Then we want to get to the horizontal asymptote. On the horizontal asymptote, we are looking at the highest exponent of the denominator and the highest exponent of the numerator. In this case, what do we notice about them? They're the same. Okay? The highest exponent of the top and the bottom are the same. Whenever that happens, your horizontal asymptote is made up of the combination of the coefficients of both of those variables. So what are my two coefficients there? 3 and 1. So I put 3 on top of 1, and that gives me a horizontal asymptote of y equals 3. Okay? So in that case, my exponents were the same. What are the other two situations if they're not the same? One's bigger, so what are the two situations in? Top one's bigger or the bottom one's bigger. So let's talk about those two situations. So let's say I had the same thing. I had 3x squared, but this time on the bottom I had x to the 5th. So in this case, you have the bottom exponent is bigger. Whenever the bottom exponent is bigger, your horizontal asymptote is always going to be y equals 0. It does not matter what coefficients are in front. If the bottom exponent is bigger than the numerator, your horizontal asymptote is going to be y equals 0. The other situation is, let's say I had 3x to the 5th over 3x, or over, 3x squared is fine, over 3x squared. So which situation do I have here? The top one's bigger. If the top one is bigger, we do not have a horizontal asymptote. We do not have a horizontal asymptote usually have what's called a slant asymptote, but no, we're not going to get into the slant asymptote. I don't think it's necessary. Okay, so those are our three situations. If the exponents are the same, we take the coefficients. If the bottom exponent is bigger, it's always y equals 0. If the top exponent is bigger, there is no horizontal asymptote. Now, what is graphically going on if I have a horizontal asymptote? We talked about what's going on with vertical asymptotes, but what's going on if I have a horizontal asymptote? I heard several different things. Sky, we'll start with you. What did you say? Natasha, what did you say?
It's going to be very close to the horizontal line, but then it's either going to
All right, so the horizontal asymptote tells me what my graph is doing out on the left and out on the right. It tells me where it's going to level off. Okay? So in this case, my horizontal asymptote is y equals 3, so that means as I go out to the left or as I go out to the right, my graph will eventually level off around the y value of 3. Okay, and what would my domain be of this? All real numbers except x equals 2 and negative 2. Very good. Yes, I'd like that written down. So let's see what this looks like graphically. Okay, I've got it graphed already. So here's our graph. What were our vertical asymptotes? 2 and negative 2. So notice, what is my graph doing as we get close to those two vertical asymptotes? It's going up or it's going down. My horizontal asymptote was 3. And notice, what is my graph doing out on the ends? It is leveling off at that y value. Okay, so that's what your vertical and horizontal asymptotes tell you about your graph. Let's try another one. All right, this one I have x times x minus 1 times x plus 2 squared over x squared minus x minus 12. So what do I want to do to get started? Factor. Somebody read that for me. Factors of 12, subtracted to get 1, so that has to be 3 and 4. And then the second time through, it says signs are different, and the biggest one is negative. So that means my vertical asymptotes are what? Negative 3 and 4. So x equals negative 3, x equals 4. All right, what about a horizontal asymptote? None. Why is it none? What's the exponent of the top? It's to the 4th in the top, and the bottom is a square, so the top's bigger. Whenever the top's bigger, I do not have a horizontal asymptote. All right, so what's my domain? About negative 3 and 4. Okay. Now, something we didn't talk about on the first one, but let's talk about it on this one. What about zeros of this function? Where do I need to look if I'm looking for zeros? Nope. Nope. If a fraction's going to be 0, what part of it has to be 0? The top does. So what makes my top 0?
0.
Positive 1, 0, and negative 2. What's going on with negative 2? Has a multiplicity of 2, so what's going on at negative 2? What should my graph be doing there? It should be bouncing, right? So I should be crossing at 0 and 1, but bouncing at negative 2. So let's see if we're good on all that. All right, so again, here's negative 2. We're bouncing. Here is 0, and here is 1, which we were crossing. My vertical asymptotes were negative 3, and what was the other one? 4. Okay, and as we get closer to those two spots, we are going down. Okay. Let's get to the third situation. Alright, so here I have x squared minus 1 over x cubed plus 2x squared minus 8x. So what do we do to get started? Factor out an x. So then that tells me I need factors of 8 subtracted to get 2, correct? Okay, so that would be 4 and 2, and then it tells me my signs are different, and that the biggest one is positive. So I have vertical asymptotes at x equals 0, x equals negative 4, x equals 2. Alright, what about horizontal? Y equals 0, Colleen, why is it y equals 0? Because the bottom exponent is bigger, very good. Okay, Kurt, what's my domain on this? Yeah, what's my domain? Say again? You don't remember that part, Kendrick? What's my domain?
All real numbers except 0, negative 4, and
All real numbers except x equals 0, negative 4, and 2. Okay? If I'm dealing with a rational function, it's always going to be all real numbers except those things. All right, what about a 0? What are my zeros on this one? Where do I look for zeros? Top. What's going to make the top 0? What can I do to x squared minus 1? Yeah, that's x minus 1 and x plus 1. Okay, what's it going to be doing at those two spots? It's going to cross. Why is it going to cross? I don't have a multiplicity that is even. My multiplicity is just 1. So that means they're going to cross. So we're going to cross at negative 1 and 1. I've got vertical asymptotes here. So what does my graph have to be doing at my vertical asymptotes? Going up or down. And my horizontal asymptote tells me I'm leveling off out the ends. Now, if I remember correctly, this is the one where I put in the equation wrong. So you're not going to see a good graph. Yes. But the horizontal asymptotes, yeah, if you notice, I missed a square on the 2x, so that screws it up. But if you notice, the horizontal asymptote would still be y equals 0, and notice that it is leveling off at 0. Notice this does have some vertical asymptotes, and notice it is going up or down at those asymptotes. Okay? So that is finding vertical asymptotes, finding horizontal asymptotes. Any questions on those two? Okay, now we're going to put it all together to help us sketch. We're going to do 2 sketches. All right, so here's my first one. I have 8 over x squared minus 4. So what do we want to do to get started? Factor the bottom. Okay, so that tells me what? Vertical asymptotes are x equals 2 and x equals negative 2. All right, what about a horizontal? 0. Why is it 0? Bottom's bigger, so y equals 0. Okay, Hunter, what would my domain be?
all real numbers except x equals 2, negative 2.
Excellent. All real numbers except x equals 2 and negative 2. So let's put our asymptotes on the graph. So negative 2 and 2. And then my horizontal is 0. Okay, notice that gives me 3 sections. I have a left section, I have a middle section, and I have a right section. So what we want to do now is pick some points in those sections to get some ordered pairs. So on the left section, what are numbers that are good to plug in? the asymptote, the better. -3 and -4. Okay, so I'm going to plug -3 and -4 in right there and see what it gives me. So if I plug -3, that makes it 9 minus 4, which is 5. So 8/5. Okay, what is 8/5 between what two numbers? 1 and 2. So when I graph it, just make sure you're between 1 and 2. And I'm happy with that. Okay, then I plug -4 in. -4 squared is 16. 16 minus 4 is 12. What does 8/12 reduce to? 2/3. So 2/3. All right, so with those two dots and knowing what a vertical asymptote does to my graph and a horizontal asymptote does to my graph, what's going on in that section? What's going on as I get close to that vertical asymptote? It's going up. So I know I'm going up. What's going on as I move to the left? It should level off. So we should flatten out at 0. Okay, let's check the middle one. So let's do -1, 0, and 1. So if I plug -1 in, that makes it 1 minus 4, which is -3, so that gives me -8/3. -8/3. So -8/3, what two numbers is that between? 2 and 3, so between -2 and 3. Somewhere in there. If I plug in 0, that gives me 8/-4, which is -2. And then when I plug 1 in there, that gives me -8/3 again, right? So that should be right there. So knowing about those vertical asymptotes and those three dots, what's my graph going to do? It's going to go down. So I know it's going to go down. Now something we haven't talked about yet on this graph that we've talked about in those other ones is, does this one have any zeros? Why not? Yeah, but how do I know that? Because the top can't be 0. In order for this thing to be 0, the top has to be 0, and the top only has a number in it. If it only has a number in it, then that cannot cross 0. So I know my graph will never cross 0. Okay, then on the right side, let's plug in 3 and 4. So if I plug 3 in, that gives me 9 minus 4, which is 5, so I get 8/5, just like I did earlier. Okay, what's going to happen when I plug 4 in? I'm going to get 2/3, just like I did earlier. Okay, so 3 and 8/5, and 4 and 2/3. So what's happening there? Yeah, it kind of is symmetrical to the one over here on the left. What do you mean? They won't always be symmetrical. All right, so there's my graph, and let's see how close we got. All right, so there's the actual graph. How'd we do? We did pretty good. So as you can see, if you use your asymptotes and then plug in a couple points, you should be able to get pretty close. All right, one more. I have f of x equals 3x squared minus 3 over x squared minus 9. Okay, so let's factor the bottom. So x minus 3, x plus 3. So that means I have vertical asymptotes at x equals 3 and x equals -3. Okay, Blake, what about horizontal asymptote? It's going to be 3. Why is it 3?
Because the exponents are the same, so it'd be 3/1.
Excellent, very nice. So there's that. What's my domain, Matt?
Your domain is
All real numbers except x equals 3 and negative 3. Okay, what about zeros? Does this thing have any zeros? Yes, what are they? Alright, so what can we do to see that it's 1 and negative 1? Take the 3 out, which gives me x squared minus 1, and then we have x plus 1 and x minus 1. So our zeros, x equals 1, x equals negative 1. What's going on with those zeros? Is it crossing or bouncing? It's crossing, good. So vertical asymptotes, 3 and negative 3. Horizontal at 3. Okay, so let's pick some numbers on the left side. Let's do negative 4 and negative 5. So I'm plugging negative 4 into the top. I'm plugging negative 4 into the bottom. So in the top, negative 4 squared is 16. 16 times 3 is 48, and then 48 minus 3 is 45. On the bottom, 4 squared is 16 minus 9 gives me 7. What two numbers is 45 divided by 7 between? 6 and 7, good. So between 6 and 7. Plug in negative 5. So that's 25 times 3 is 75, minus 3 is 72. And on the bottom, that is 25 minus 9, which is 16. That one's a little bit tougher. But we just learned that 16 times 3 is 48. And 48 plus another 16 is 64. So that means it's got to be between what two numbers? 4 and 5. Okay. So what's that section doing? Going up on the right, leveling off on the left. In the middle, I always like to do 3 in the middle. So let's do negative 1, 0, and 1. So if I plug in negative 1, what does that give me in the numerator? 0. I already should know that, right? Why should I know that already? Because we found out our zeros are 1 and negative 1. So I already know those two are 0. Okay, so then I plug in 0, which is negative 3 over negative 9, which is 1/3. So with those 3 dots, what's going on? It's going down. All right, then we need the right side. So let's pick 4 and 5. Okay, what's going to happen when I plug 4 and 5 in there? We get the same number as negative 4 and negative 5 gave me, right? Because both of these x's were squared, so it's going to give me the same numbers. So, just like on the last one, this one ends up being a mirror. So there's what I've got. Okay, vertical asymptotes told me what was going on. Horizontal told me what's going on at the ends. I've got my zeros. So let's see how close we got. All right, there's the actual graph. How close were we? We did pretty good again. Okay. So, vertical asymptotes, how do we find vertical asymptotes? Back to the bottom. What makes my bottom 0 right now is going to make us vertical asymptotes. Down the road, it could also give me something called a hole, but you're not going to run into that right now. Okay, and how do I find horizontal asymptotes? Look at the exponents. I've got those 3 situations. I'm either gonna use the coefficients, it's gonna be 0, or I'm not gonna have one. Okay, and once I have all that, go ahead and find the zeros. Sometimes the zeros are hard to find. If you're spending a lot of time finding the zeros, don't worry about finding them. Okay, but if it's pretty easy to find zeros, like it was on that last one, go ahead and give me the zeros. Give me the domain, give me a few points in each section, and then graph it. You should be able to get a pretty good sketch. And then just like we did, I would recommend that you would check your sketch to see how close you got.